please call me Hiro. Basically working at Waseda University, based in Tokyo, Japan. And so I'm very happy to serve as the chair of this session titled Software Applications. So we are going to have three presentations in terms of your software applications. And then, okay, so first speaker is Chen Liu from Shanghai Key Laboratory of Trustworthy Computing, East China Normal University. And the presentation is titled Multiform Logical Time and Space for Mobile Cyber Physical System with Automated Driving Assistance System. So, so Chen, if you are ready, please start your presentation. And you have 15 minutes for your presentation and followed by 5 minutes discussion.
Okay. Is that okay?
Yes, we see your slides. Thank you.
Okay. Now I can start. Hello, Mr. Chairman, honorable guests, ladies and gentlemen. It's a very great pleasure indeed for me to be able to attend this meeting. Now, I would like to present my work, Multiform Logical Time and Space for Mobile Cyber-Physical System with Automated Driving Assistance System. Next, I will introduce my background. In Automated Driving Assistance System, as known as ADAS, there are three typical steps: perception, plan, and act. ADAS has various sensors to perceive the surrounding environment, collect data, identify, detect, check static and dynamic objects, thereby providing safe driving trajectory plan. Then, the vehicles will enforce that trajectory plan. But in recent years, there are many accidents happened. A number of them as shown in the table. Some are caused by the Tesla, Uber, and so we can say it is very important to ensure the safety of driving rules for autonomous vehicles. And moreover, driving rules relate to time and space. So that makes things more difficult. In this work, we want to build specifications for safe driving rules, which are related to time and space. And also, they are dynamically changed through time. So in this work, there there are some existing approaches for expressing time and space properties. Spatial temporal is a general way, such as spatial temporal for closure space, spatial temporal for single spatial temporal. There are all extending temporal or spatial logical. Also, low-level safety assurance is proposed. Mobileye present a white box interpretable and mathematical model, named responsibility-sensitive safety, as known as RSS. However, due to the mobility, elements might dynamically enter and exit the scene. The logicals and the low-level safety assurance cannot deal with dynamic changes constraints in a unified way. So in this work, there are three main challenges. And one is the first is the modeling of the environment of the car, which is the spatial temporal modeling. It is still an open problem. And the second is how to express time and space constraints in a unified way. And the last is how to modeling the mobility. We know the mobility causes sense uncertainty, so it is very hard to deal with. In this work, we use the cloud constraint specification language as known as CCSL to capture the time and space constraints in safe driving rule specifications. Cloud constraints specification as known as CCSL. CCSL relies on logical clock, schedule, and history to define syntax and semantics of CCSL expressions. And we can say in this table. And here the logical defined as an infinite sequence of ticks mapping to the system events, which means every event, we can say every event could map to the to a logical clock. And the schedule is an infinite sequence too, which consisting of a set of triggered clocks at any step. And the history records the number of clock ticks. Based on this notations and these expressions as shown in the table, we can express time constraints for any system. And then, based on CSSL, we introduce our main work. Here is the framework. We propose a pattern to build specification for self-driving rulers. The pattern instantiation with the flash scene provided by low-level physical simulator, which means that the sense changes through time. So we need to update the constraint system dynamically. With the specification, the observer could monitor the trajectory plan and then output whether the trajectory plan is safe or not. Self-driving ruler specifications consists of time and spatial constraints. So we show how to build the specification next. When building the specification, we need to consider the elements in the scene. In our setting, a scene consists of a certain number of players, which means some active elements, such as cars, pedestrians, and bikers. And the passive elements, we name the objects, such as road lines, crossings, and traffic signs, and the ego car itself. And for each generic element type, we define a number of areas for safety. For example, the ego car, we said it includes the forward front collision area, front danger area, and the front view area. And the view area it means the area that the ego car can perceive. And similarly for the right, left, and the back. And here we present a near notation, which means which is abstraction of abstract notation. It depends on the type of the element ID. It has different definitions for different elements. Here we can say the ego car. There are the areas for each direction and the collision area. And for the other cars, we have the near. And here the near, it means the area occupied by the other cars. And more then we can, from the each direction of the view, we could know which player object is to which direction of the car. And so as this area moves through continuous time in simulation, then we present the area trajectories. Given area A, we use A of t represent the area A at time t. To express the relation between this area, we present special relations, including equal, belong to, intersection, and disconnect. And it is very easy to understand. And then which allows us to define a spatial events, join, disjoin, include, and exclude. They are all generated by the interaction between area trajectories to express the transition between the relations. And so from the spatial events, we can get the corresponding logical clock. Then we can use CSSL to express space constraints, which means CSSL can express time and space constraints in a unified way. Moreover, to express more complex time-related requirements, such as within or after some seconds or meters, we present two extensions with in and after. For example, C1 is defined by C2 with in D time unit, where D is the multiform logic time. If D ticks, then the next tick of C1, if C2 ticks, then the next tick of C1 should tick within D time units, and after has the similar semantics. It used for the bounded future property. So based on three spatial events, we present a safe specification pattern, a high-level abstraction of safe driving rulers, which states whenever a potentially problematical situation occurs, we need to monitor its evolutions until there is easy recovery to a normal safe case or failure and possible crash. The start check means corresponds to the potential problem, and the recover is the result of driving conjunction commands. And the failure procedures more serious problem, such as collision. Then the pattern says once the start check occurs, then wait to recover or failure occur. While receiving a flash scene, we need to update the constraints. But how can we update the constraints while receiving a flash scene? One way is rebuilding everything. And we know it takes too many resources and inefficient. In our work, we add new constraints for the newly appearing elements and remove constraints for the disappearing elements. Based on the sensors, you can get which is the newly appearing and disappearing. And the right is the processes for updated the constraints. Now I will introduce the case in our work. The case is a highway. There are two scenes, A and B, and the eagle car drives along the middle line. So firstly, we use the low-level simulator to provide a dynamically changing environment. Here we use the color simulator, and the color uses the Unreal 4 as the server and the Python to write the script as the client to simulation. And we can say the left picture is the Unreal 4 server, and the right is the simulation. And then here are the implementations of the areas and area trajectories and spatial events. And note that for each spatial event, it accompanies with two attributes, a distance and a time step, which are used for verifying the within and after operators. Then we can build the specification for highway based on the areas and the spatial events. For the front, here is the example for the front car. The eagle car has a front danger area. In this case, safe situation means that the front danger area is disjoint with the front car, and the danger area danger means the front danger area intersects with the front car, and collision means the collision area of the eagle car intersects with the front car. So in this case, the safe driving rules is that once the front danger area of the eagle car intersects with another car, we expect a recovery within a given maximum response time to prevent a collision. And that's why we need a within and after operators. So the formalism expression as shown in the following. And then to dynamically update the constraints, here we build a table about the players of the eagle car in each direction for A and B. We can see that from the scene A to B, the left neighbors of the eagle car don't change. So the constraints for the left needn't update. And for the right, a new car C6 enters. Then we need to add a constraint of C6 for the right direction. For the front, the C1, the C5 exists the same. Then we need to remove a constraint of C5 for the front direction. For the back, C1 and C4 exist the same, then we need to remove all the constraints for the back direction. In this way, we can dynamically update the constraints efficiently. And this is the simulation result, and here is the output when a new thing B enters in the receiving by the equal car. So in this work, we present we present a safe specification. We present a safe specification pattern to build a specification for safe driving rulers. By introducing the notation of spatial events, we can use this SL to combine the space and time constraints combine the time and space constraints, which means we can use this SL to express space and constraints in a unified way. And by putting forward the two CCSL extensions, CCSL can express the constraints for a foreseen future. And we using the color to simulate the specification generation for autonomous vehicles. And in the future, maybe we will do the safety verification with the specification pattern in color. And we use the verification result as the feedback to make a better trajectory plan. And that's all. Thank you.
Thank you very much for a very interesting talk. So now we have several minutes for discussion. So for all participants, do you have any questions or comments or suggestions or any discussion? Okay, then I may start the discussion. So first of all, it looks really nice and as a quite nice in application of such formal method to for such a possible situation. And I'm curious that so you propose a highly abstract specification pattern, right? And yeah. So I'm curious that is that single pattern is enough to cover various different situations, or do you have a plan to have many more patterns to address various complex situations?
Yeah, the pattern in this three template events, but each template event we use the CSL expression to do the definition, because we can use CSL to define a new event or new logical clock, because each event we can use the logical clock to express. So we use the CSL expression or CSL definition to implement the start, check, recover, and failure. Then we can recover many situations. And for example, we can use the within and after for the start check between the recover and the failure. Here start check and the recover has a relations. We can say at the example, we say within and after some seconds or some meters. So we can use the within operator from the CCSL, and maybe we can use the any operators from the CCSL to express the specifications. So it's not very simple. I don't know.
Okay, I understand that. Yeah, okay. Perhaps I hope I understand that. So your pattern approach can address various possible applications, although it requires more concrete generation or addition of actual events and.
Yeah.
Okay, I see. And then any other questions or comments from other participants? Okay, then I have another question that is about performance in terms of monitoring and also update constraints. And So if I understand correctly, your approach might be applicable at runtime, right?
Yeah.
If correct, then what about runtime performance of such constraint updating and also, yeah.
The performance of the runtime here, we didn't get the result now because we don't have a better machine. Our machine not very good to run the Java and our simulation in a same computer. So now we can do the we can say it is feasible. But we didn't check its performance.
Okay. So it can be a future. Okay, I understand.
Yeah, and maybe we will do that in the future work because we are now to do the safety verification in a better machine.
Okay, I see. Okay, then any other question or comments? Almost it's time to finish this presentation, but any additional question or comment from audience? Okay, so thank you very much. That's a very great talk. Thank you very much.
Thank you.
Okay, then I hope we are now having second speaker, Zhang. Oh yeah, so here we have Zhang. Okay, so second speaker is Zhang from National University of Defense Technology, and the presentation is titled "An Empirical Study on the Influence of Social Interactions for the Acceptance of Answers in Stack Overflow." So, Zhang, please start your presentation.
Hello, can you see the screen?
Yeah, now we see your screen. Okay.
Okay.
Hello?
Hello, everyone. Hello. Hello.
Yeah, we hear you, but it's quite hard to hear.
Hello, can you hear me?
Now you can hear you. Thank you.
Okay. Hello, everyone. I'm Zhang from the National University of Defense Technology, and the topic I report is an empirical study on the influence of social interactions for the acceptance of answers in Stack Overflow. Next, I will report from 7 aspects: background, motivation, research questions, study decision, results, discussion, and conclusion. Recently, question and answer communities have emerged as a popular medium for online knowledge sharing, providing a large amount of information that can be referred by users when meeting problems. Among these QA websites, Stack Overflow is one of the most famous and popular social QA websites. The questioner can choose an answer as the accepted answer in Stack Overflow, meaning that this answer helps him or her solve the problem. Many previous works have found that much information related to the content of question and answer can affect this process, such as the structure of the answer. Instead of focusing on information about question and answers, some researchers propose the assumption that the users with a high reputation tend to produce high-quality answers and use it to rank answers. Evolution from other answers can also be as a basis for evolution, such as votes and comments. Users interact with each other in the process of participating in the community, and gradually form an impression of each other. However, social interactions between the questioner and the answer have never been considered as factors that can affect users' acceptance of answers in previous works. On the one hand, when users encounter similar problems, these accepted answers can serve as an important reference for them to solve the problems. Thus, The decision process of accepting answers is important for community development. It is necessary to study the factors that can influence the decision process of accepting answers in Stack Overflow. On the other hand, previous works have pointed out that social interactions is likely to affect the decision in the programming-related platform. Due to the influence of the social interactions for the decision in the other communities, we aim to investigate whether social interactions between the questioner and the answer are popular in Stack Overflow. It is necessary to study the impact on the decision of accepting answers brought by this if the answer is positive. Due to the protection of user privacy by Stack Overflow, we cannot obtain voting data of users, so the social interaction we study in this paper including community and answering. Firstly, we divided the time of the social interactions between the questioner and the answer into two stages. Stage 1, from the time Stack Overflow is established to the time put when the answer is posted. Stage 2, from the time put when the answer is posted to the time put when the questioner marks accepted answer. The social interactions that occur in the stage 2 are often the communication between the questioner and the answer through comments on the answer, which is popular according to previous works. Then, we study the popularity of social interactions occurring in stage 1 in the past 10 years by analyzing data of Stack Overflow from July 31, 2008 to December 31, 2019. For an answer, if there is an answer interaction or community interaction between the questioner and the answer before the answer is posted, the answer is called type 1. Otherwise, it is called type 2. The change in the proportion of type 1 answer to all answers in the past 10 years is shown in the figure. As we can see, the proportion of type 1 answer is showing an overall upward trend from 0.125 in 2010 to 0.134 in 2019, meaning that there is about one type 1 answer for every 7 answers in 2019. Thus, we conclude that social interactions between the questioner and the answer in stage 1 are also common. Based on the findings of our analysis, we propose to study the impact of social interactions on the acceptance of answers. In particular, we desire the following two questions from the method of quantitative analysis and qualitative analysis. RQ1, do social interactions affect the user's accepting answer? If so, to what extent? RQ2, how do users perceive the impact of social interactions on acceptance of answers? Next, I will describe the decision of our empirical study, which consists of the data set, answer acceptance model, and implementation. For RQ1, since the official data released by Stack Overflow is as of May 31, 2020, we select all question answer pairs from January 1, 2020 to May 31, 2020 for logistic regression analysis. For each question answer pair, we remove the answer that is answered by the questioner and the answers that are posted after the questioner marks accepted answer. There are around 0.29 million accepted answers in the dataset. Considering that the data in a short period of time does not fully reflect the user's social interaction, and the data in a longer period of time may interfere with the timelines of the reflected user's social interaction. We add the data for the 2 years before 2020 to calculate the social relationship among users. For RQ2, according to our experience and referred to previous study, the response rate of the questioner is usually between 10% and 30%, and we think 100 responses can represent the views of the community users. Thus, our target population comprises 1,000 users. Then, I will introduce how we build the answer acceptance model in detail. When questioner looks through answers in Stack Overflow, they can get the following information: content-related information, such as text and code; user-related information, such as reputation; computation-related information, such as the number of answers to the question; prejudgment-related information, such as comments and score. And they can also get the social interaction history-related information. We will build the model based on the above information. First, I will introduce the social-based features, which is extracted from social-related information. Considering the direction of social interactions, we extract the features based on the social interaction between the questioner and the answer at different stages. We consider social interactions of asking and commenting in stage 1. For stage 2, we consider comments on the answer. The description of these features are shown in the table. For the relation established by the social interactions, we extract the time information and frequency information of these interactions, such as the equation 1, 2, 3 shows, and the CLIJ in equation 2 and ALIJ in equation 3 are the relationship established by the community and asking. Previous studies have found that some answer features can influence the likelihood of an answer being accepted. In order to study the influence of social-based features on accepting the answers, we select some answer features that have no measurable influence on the decision process of accepting answers in CQA from previous studies. The details and the calculation methods of these features are described in the corresponding reference in table. Then, I will describe the implementation of methods used to answer research questions. For AQ1, it extracts the social-based features, extracts the non-social-based features, and establishes the logistic regression model. Recording the extraction of social features for stage 1, the baseline of in equation 1 to 3 refers to 2 years before the time the answer is posted, and the deadline is the time when the answer is posted. For stage 2, the baseline is the time the answer is posted, and the deadline is the acceptance time. For AQ2, we use 3 choice questions to collect user personal information, 1 lecture skill questions to compare the impact of social interactions on accepting answer with the impact on other judgments, such as upvoting, downvoting, accepting answers, and not accepting answers. 1 lecture skill questions to compare the impact of social-based answer features with the impact of non-social-based answer features on accepting answers, and 1 open-ended question to ask a response about their opinions about the popularity of this impact. Participants is voluntary, and the estimate time to complete the survey is 5 to 10 minutes. Next, I will introduce the results. For AQ1, we first only use non-social-based features to establish logistic regression model, and then use social-based features and non-social-based features to perform logistic regression analysis, and the results are shown in table. We can inform that the social-based features can improve the fitness of the model in explaining accepting answer of affect users accepting answers. We sort the variables in descending order of some circle, and the figure shows top 10 features. We can find that social interactions that occur in stage 2 are more influenced than that occur in stage 1 in affecting the decision of accepting answers. For AQ2, we obtained 132 responses. 85.61% of the response have contributed to Stack Overflow more than 5 years. 8.33% of response have contributed to Stack Overflow in 3 to 5 years. A few response have experienced a failure in that 3 years, and only 1 respondent have never contributed to Stack Overflow. So users participating in the survey are very familiar with the Stack Overflow, and their opinions about the impact of social interactions are very positive. Respondents think that social interactions have a great impact on the acceptance of answers than other judgments. However, they select the social-based features as the least influential features, maybe because they want to behave as fair or they are not aware of the impact of social interactions. Also, 47.3% of them think the impact of social interactions is more positive. However, 14.86% of them think it is negative. The results of them are neutral. From our results, we can distill several implications for different stakeholders. For QA websites, we provide some suggestions to the community decisions, such as animals answer or give the reason for downvoting. For community users, we suggest that only use the quality of the answer to evaluate the answer and to minimize the impact of subjective emotions. For researchers, they can analyze this phenomenon and map from the reasons why respondents don't choose the social relationship the most influential features. For software engineering community, they can analyze the decision-making patterns for users to choose the best knowledge they think and recommend the most satisfactory knowledge for them. In this study, first, we propose a comprehensive answer acceptance model that integrates the social-based features and non-social-based features. Second, we propose a method to calculate the social relationship among users in Stack Overflow and investigate the influence of social interactions for the acceptance of answers by performing logistic regression exercise. Third, we further conduct an online study of 132 Stack Overflow users to get their opinions about the impact of social interactions on the acceptance of answers. This is the end of my report. Thank you for listening.
Okay, so Zhang, thank you very much. That's also very nice talk. So any questions or comments? Any discussion from participants? Okay, then again, I can start some discussion. So that's a quite interesting approach to discover such a possible hidden impact from the viewpoint of a social interaction. And so I'm curious that what is the takeaway? I mean, how to utilize, how to use such findings? Do you have any opinion or?
I think our findings can use to be such as explore the decision process patterns for users when they choose the best knowledge they think. So it can use to recommendation system.
Okay, I see. Oh, okay, I understand that such possible usage. Okay, thank you very much. Any other questions or comments?
Thank you.
Yes. Any other questions or comments? We have some few minutes for further discussion. So any question or comments? Okay, so then I have another question about the relation between such a survey result and also quantitative analysis. So you got a nice survey response or results, right? By conducting online questionnaire-based survey, right? So I'm curious
Yes.
that how they actually behave in past question and answer sessions. Yeah, I see that survey respondents were somewhat positive and somewhat negative, and so so did you see how they actually behave? For example, some respondents mentioned that, okay, positively impact, then so they actually, they have any.
Some users, some participants think the social interactions is positive because they think if they're familiar with the question or the answer, they can get some additional information from users. But some users think the social interactions are negative because they think there are some wrong words or implied words for the new users. It is not easy for the new users to participate in the community. So think and some users also think that people tend to upvote to the users they are familiar with, and it is not fair to evaluate the quality of the answers. So that's their opinion about the social interactions in Stack Overflow.
That's interesting. Okay, any other question or comments? Then I may have additional one more question, okay? If you know question or comment from audience. Okay, then, well, that's interesting. And okay, I'm curious about some side effect. I mean, such social interactions are visible to all participants, right? So,
yeah.
Did you see that, for example? Okay, so I am a potential answer, okay, but I didn't make any social interactions, but I can see some social interactions among others, and then okay, so I can see some information taken from such others social interactions, and then I can provide some good answer.
Yeah. Sorry, I don't catch the problem.
Oh, I see. I mean that social interactions are not are visible to all participants, right?
Sorry, my internet is not stable, so I just can't leave the room. Sorry.
No problem.
Sorry.
Okay, I see. Well, just minor comments because I felt that all social interactions are visible to all participants, so that's why someone may take a look at comments and discussions conducted by others, and then post some good answer, and I may think such possible usage of or stealing social interactions from others. Well, I feel something like about that.
In our study, we found that because we divided the time of social interactions into two stages. Stage one is from the stable flow is established to the answer is posted, and the stage two is from the question from the answer is posted to the answer is accepted. And we found that the second the social interactions occurred in stage two is more influence in the in accepting answers. We think that in stage two, users can share their opinions about the answer, especially if the questioner can't understand the answer. They can answer more questions through the comments on the answer to help him understand the answer. So I think the social interactions play a major role in the stage two.
Okay, I understand such importance. Okay, I understand. Okay, Then maybe last question or comments from the participants. Okay, no. Okay, so thank you again. Thank you very much. That's a great talk and discussion. Thank you very much.
Oh, thank you.
And finally, we are going to have a third presentation. It will be provided by
Yes,
Figalist, yeah, from Siemens, and the presentation is titled "Mining Customer Satisfaction on B2B Online Platforms Using Service Quality and Web Usage Metrics." Okay, so if you are ready, please start your presentation.
Yes, thank you for the nice introduction, Hiro. My name is Iris. Hi, everyone. I work at Siemens Corporate Technology, and today I would like to present our paper, Mining Customer Satisfaction on B2B Online Platforms Using Service Quality and Web Usage Metrics. And before going into the details of our study, I would like to provide a little bit of background information on why we decided to do this study in the first place. So since the study is very much focused on B2B online platforms, I think it's important to highlight the difference between B2B and B2C customer relations. So for one, in B2B contexts, you have a significant lower number of customers with much higher transactional values. So this makes the relationships often a little closer and more personal. And then there's also the fact that the customer is not equal to the end user of a product, but both kind of directly or indirectly influence the overall customer satisfaction. And this fact makes it much more difficult to assess customer satisfaction because oftentimes it's difficult to get access to these end users, and it's often not possible to do customer surveys or interviews. And one general issue with existing approaches when assessing customer satisfaction, for example, by doing interviews or surveys, is that, that they are outdated really fast, especially in times of continuous deployment. And then you'd, of course, have to, conduct interviews after each new release. And that's why the goal of our study was to find a way to measure customer satisfaction in a fully automated and quantitative way. Now, to achieve this, we first conducted a literature review, and as relevant research topics, we identified customer satisfaction, service quality, and web usage mining. And based on the results of the literature review, we then derived a model for measuring customer satisfaction by extracting, interrelating, and arranging the components we have extracted from the literature. And in order to validate our model, we instantiated it in a real-world B2B online platform. Now let's take a first look at the results of our literature review. So this graph specifically highlights the antecedents and consequences of customer satisfaction that we have identified in the literature. As antecedents, there are, for example, the expectations of a customer or the customer perceived value, which have a direct impact on customer satisfaction. And on the other side, there are the consequences of customer satisfaction. So depending on the level of customer satisfaction, the loyalty may increase or decrease, for example, or the repurchase intentions may change, or the usage behavior is often different. And also very interrelated to customer satisfaction is the term service quality. And because this relation seemed somehow relevant in existing literature, we decided to take a closer look at this as well, which I would like to present on this slide. So in the area of service quality, there exist so-called service quality scales, and each scale consists of several dimensions, like the one you can see in the table here. And the scales are selected depending on the context you're in. So for example, our case was in the context of B2B and platform as a service and software as a service. And for that specific context, we selected a scale that consists of these 6 dimensions: rapport, responsiveness, reliability, flexibility, features, and security. So rapport is mostly related to support and individualized attention for the customer. Responsiveness is related to the availability and performance of the service and the responsiveness of the support staff also. Reliability describes whether services perform timely, dependably, and accurately. Flexibility relates to the customer's flexibility of making either contractual changes or requesting functional or technical changes. Features describes how well the key functionalities meet the business requirements of the customer. And lastly, security is related to the measures that are taken to avoid unintentional data breaches or corruptions. Now, since our goal was to quantitatively measure customer satisfaction in an online context, we also considered it important to investigate the concepts of web usage mining. And this figure you can see here now highlights the overall process of web usage mining. So first there is a data preparation phase during which the data, which is mostly web and application server logs, are extracted and is being pre-processed before being stored in the so-called user transaction database. And now during this pre-processing, you also take, for example, the site content, further domain knowledge, or other databases like the sales data or customer data into consideration. And then in the pattern discovery phase, the usage transaction database is accessed in order to apply usage mining on the data. So for example, statistical analysis or association rule mining or some clustering. And this then results in patterns, which are used for pattern analysis, and for example, during which patterns are characterized in order to ultimately come up with some user models of your user or of a customer's users. Now this table shows an overview of common web usage metrics that are used in web usage mining. So for example, you have the number of page views, the number of sessions, or the number of users. The bounce rate is the ratio of sessions with only a single page view, while the stickiness of a page is the inverse metric of that. There's also the page view or session duration, or the number of page views per session. The visit frequency describes how frequently the users of a customer are using the product, and the visit recency is the number of days that elapsed since the last visit. Now, based on the results of the literature review, we derived this model for measuring customer satisfaction. And the model is divided into two phases, one the model preparation phase and the model application phase. And it's also divided into two domains, which are customer satisfaction and web usage mining. So initially, you select a service quality scale depending on the domain-specific aspects of your case. And based on the scale, you end up with a set of service quality dimensions, which you can then also validate and adjust according to your needs. And for each dimension, there's a number of service quality metrics that are identified first and then merged into a common score formula. Now, this score formula is used for calculating customer satisfaction scores of the customers, and depending on their score, customers are then grouped into so-called customer satisfaction classes. Now, on the other side, we have the web usage mining, and we have extracted web usage metrics that we have identified in the literature. So you first need to process, the web server logs or other usage data you might have in order to calculate these metrics, and then store it in a user transaction database. And since we are in a B2B context, these metrics are merged on a customer level based on the respective users. And in the next step, the previously assessed customer satisfaction classes are then combined with the calculated usage behavior of the respective customers of the respective classes also. Because in the literature, we found evidence that usage behavior is a consequence of customer satisfaction. So that's why I believe that this is a fair thing to do. And then by analyzing the usage behavior within the customer satisfaction classes, we can then kind of use the usage behavior to validate the customer satisfaction scores. And we can also use the usage behavior to derive insights of the usage behavior and the corresponding customer satisfaction score, and also to classify new customers solely by looking at their usage data or usage behavior. Now, in order to validate this model, we instantiated it in a real-world B2B online platform, which in our case was a platform provider for healthcare applications provided to, for example, hospitals. And now the first step was to select an appropriate service quality scale that for our case consists of the dimensions you can see here on the table. We also conducted interviews with so-called digital solution experts of the platform provider in order to rate the importance of the dimensions on a scale from 1 to 5. And these experts are, for one, the first contact partner for the platform's customers, but they are also technically trained by the development team, and that's why we think this is an appropriate expert, or these are appropriate experts to interview for this rating. And then for each dimension, we also investigated the metrics that were available in our data sources. So for example, we have the tickets per month, or the open delayed ticket, or the availability and latency, or the feature request tickets, and so on. Now, in the next step, we use these metrics to build our customer satisfaction score formula. So first, we have all the service quality metrics that are initially weighed equally. And we then combine the service quality metrics of each dimension to a dimensional customer satisfaction score, which can then be combined to an overall customer satisfaction score. And we use the expert rating of the dimensions as weights for calculating the overall customer satisfaction score. And sometimes not all metrics are available for every customer. So for example, if a customer never opened, or a user of a customer never opened a feature request ticket, of course, we don't have any information on the, for example, feature dimension. So in that case, we normalize the weights to still add up to 1 in the end. Now let's take a first look at the results of these calculations. So on the left side, you can see the customer satisfaction scores of each dimensions. You can see the mean and median values, and also the standard deviation and the number of customers. And the plot on the right shows the overall customer satisfaction scores. So you can see that there are only very few dissatisfied customers, also a few very satisfied customers, and the majority of customers has a score like between 0.7 and 0.8, which is a very normal distribution for customer satisfaction, actually. So in order to now being able to validate these scores, we then analyzed the usage behavior of the customer's users. So we calculated the usage metrics for all the users of each customer. And this table shows the metrics that we have calculated. We always calculated the mean, median, and standard deviation, and merged it across all users of each customer. So the mean number of page views, for example, across all customers were 431. The mean page views per user and month are 10.1. On average, users spend 8.9 minutes per month using the product and looked at 6.2 pages per session, for example. What is very interesting to see is that the minimum recency is quite high, with a mean of 77.8 days, which means that users on average only used the application after almost 80 days, which is not necessarily a good sign. But yeah, that's what we have observed. And now, depending on the customer satisfaction scores, we assigned the customers to the customer satisfaction classes, which are dissatisfied, neither satisfied nor dissatisfied, and satisfied. And we then assigned the classes to the usage metrics of the respective customers as kind of labels, and then compared the usage behavior of the classes with each other. And we had to neglect the dissatisfied class because there were only 4 customers in there. And so instead we focused on classes number 2, which is the neither satisfied nor dissatisfied class, and class 3, which comprises the satisfied customers. Now on the left box plot, you can see the page views of customers within the 2 classes. And it stands out that the mean and median number of page views are higher for customers in the satisfied class, so in class 3. And on the other hand, if you look at the minimum recency, so the number of days between usages of the users, that number is lower for customer in the satisfied class, which is a good sign because then these users tend to use the product more often. In addition to that, we trained a decision tree to predict the customer satisfaction class just by looking at the usage metrics we have extracted. And we actually ended up with an accuracy of 91.2%, which is quite good. And therefore, we believe also in the meaningfulness of these customer satisfaction scores. Now, to conclude, we can say that we were able to successfully calculate customer satisfaction scores based on service quality metrics. We validated the customer satisfaction scores by investigating the usage behavior, and we found a significant difference in the usage behavior across the customer satisfaction classes. And the main advantage of this approach is definitely that it allows the measurement of customer satisfaction in a fully automated way. And also it doesn't require direct customer contact or even effort on the customer side. So the customer doesn't need to fill out surveys, or in this case, the customer's users don't need to fill out surveys. And yeah, which is, often the case when you assess customer satisfaction in different ways. So these are the main advantages, and also the platform provider we have developed this for was really happy with this approach. Now, this is the end of my presentation today. Thank you very much for your attention, and I'll now be happy to answer any questions you might have.
Thank you very much for that really nice talk. So any questions or comments? Okay, so then I can start discussion. So that's a quite interesting approach, and so I'm curious about how the model and framework and approach can be applied to any business, because your approach is targeting not B2C but B2B, right? So each business has different business process, such, for example, okay, healthcare businesses or item transaction business. So do you think your approach it can be generally applied to any business, or?
Yes, I think so. So, I mean, the motivation of us came from being in a B2B context and don't having access to the end users. But what you basically do, there are several service quality scales. I only presented one of them in this talk today, but depending on your context, there are different service quality dimensions. And then you just have to look what you have available as metrics. So in our case, it was mostly around ticket data. So whenever you have that, you can use these metrics, but there might also be other, logs or like availability or reliability metrics that you might have. So it really depends on what you are collecting, because of course, if you don't collect the data, you can't really measure it. But you don't need to specifically have these metrics that I presented today. You can also use other metrics that fit into that dimension. And yeah, so that's why I think it can be applied to other businesses as well.
Ah, that sounds good. So you have now quite a general model, but it can be applied to any business by having or extending metrics corresponding to the target domain. Okay, I see. Any other questions or comments? Quite okay. Then minor questions that so you are applied decision tree, right? For classification. So but often decision trees may suffer from overfitting, and so why did you choose decision tree, or did you consider some other classification models, or?
Yes, we also we tried out, I think it was logistic regression as well, but we ended up with a higher accuracy using the decision trees. And we used, I think it was almost 2,000 samples for training, and then almost 1,000 samples for testing. So the accuracy was quite good. So that's why we stick with the decision tree. But there are, of course, many different approaches that you can use for that.
Right, random forest or okay. Anyway, but still, we got a nice result. Okay, I see. Okay, then any other questions or comments, or? Okay, so okay, then one more thing. I'm feeling that your more, some portion of your approach might be applicable not only to B2B but also B2C, right? Especially web metrics can be applied, but some metrics might be changed for B2C. Do you have any view, or?
No, absolutely, I agree with that, and it could probably be adapted to B2C. We didn't want to claim that it did, or that it is applicable to B2C, because we didn't have the case to validate it. Of course, I'm convinced that it will be, or it could be applicable, because you can just use the metrics according to the dimensions that you have available. But yeah, that was mostly driven by our motivation, because we were in that B2B context. And yeah, that's why we decided to first focus on B2B.
Okay, I understand. I see. Yeah, and also data is very important. Yeah, too. Yeah. Okay. Okay, then any final question or comment or? Oh, yeah. Oh, yeah. Okay, here's a comment. Okay, so here's a comment on the chat. Okay, so I will read that. Nice problem. It is. Did you apply your model to other training data besides data from Siemens business?
No, we only had that one validation case. So it was a deductive approach. We derived the model from the literature and then applied it to that case I presented today. But I'm actually at the moment working on applying it to a different Siemens external case, but this is unfortunately not part of the study yet. But we are reusing it at the moment, so that's, I guess, a good sign.
Yeah, that's great. So we may see another presentation, maybe next AppSec. Or...
Yeah, maybe.
Okay. Okay, then any other question or comment from audience? Okay, actually, it's almost time to finish this session. So once again, thank you very much. That's a great talk and discussion. Thank you very much.
Thank you.
All right, ladies and gentlemen, we got a really nice talks and discussions in this session titled Software Applications. So any final comment or question in this session we may take? Or if you know problem, then it's almost time to finish this session. So once again, thank you very much for coming to this session titled Software Applications. And I hope all presenters and also all participants enjoy this session. So once again, thank you very much and stay safe and stay healthy. And also please, please enjoy the rest of this conference. We will have one more session just after this session. Okay, thank you very much.
Thank you. Bye-bye.
Hi. Bye-bye. Okay, so conference staff, do I have something to do additionally, or this is it? Nothing? Okay, thank you very much. So